Good morning. All right, so today will be the last investigation of this today will be the last activity of this investigation, which is 2.3, interpreting exponential functions from their graphs. So, other words, finding equations of exponential functions from their graphs. So I want you guys to not stress, because it's really similar in terms of substitution, like we've learned in the past, of finding the equation of a y-intercept, of the slope-intercept of y equals mx plus b when given 2 points. We just substitute when we know our letters, and we do the math accordingly. We also have to remember how to simplify exponents. For instance, if I had something like, and you'll see this in some of today's and tomorrow's work, if I have like x to the second, y to the third over x to the fourth y. Like when we divide our exponents, when we divide our similar expressions, similar variables, x over 2, x to the second over x to the fourth, we always subtract our exponents, so we're left with just 2x, x squared on the bottom, and I got 3 because I do 2 minus 4, which would be negative 2 upstairs, or just positive 2 downstairs, bringing back our memory, and 3 minus the invisible 1, this is y to the power of 2, or something else you'll see in today and tomorrow's work. If I have 3x to the second, y to the third, all to the power of 2. Remember, when the power is raised to the power, you guys are always allowed to multiply. Remember those rules. I attribute to every single thing. I bring it there, I bring it there, I bring it there. So this would simplify to 9x to the fourth, y to the sixth. Bringing back some memory joggers for you. Now, the purpose of today's lesson, you'll see how all this plays a part. And last but not least, the last thing you got to remember, useful things when doing this, you're using proportions and cross products. Now, for the sake of what we're doing today, we're going to assume that you're never going to know what the y-intercept is. So we don't know what this is. All I was able to identify was this point and this point, and that point and that point. Now, it's very helpful when you have consecutive numbers, like 2, 3, and 2, 3, rather than 2 to 4. We'll learn that later next week. Right now, let's just understand how to do this. So the bread and butter of this, I'm going to do this one first. We know that the equation is y equals ab to the power of x. Now, on a side note, if I were to do this, and this is where I want to see the similarities between this and y equals mx plus b. I'm going to do a quick little brain jogger. So if I have something like x is 2, y is 2, and x is 4, y is 6. I don't know what this answer is going to yield, but I do know I got to find the slope of this first, right? So I would do, remember, x1, y1, x2, y2. I do not want us to forget this because it's really important. Change in y. 6 minus 2 over 4 minus 2 equals 4 over 2, which equals 2, okay? So that's our slope, and now we can choose either one of these points, remember, to find the equation of this line, because right now I got y equals 2x plus b, and all I do is I take one of these 2 points, I'll just take this one, replace them with x and y to solve for b. So 2 equals 2 times 2 plus b, 2 equals 4 plus b, subtract 4 from both sides, I get negative 2 equals b. So the equation of this line is y equals 2x minus 2. So that was the process that we spent a lot of time on in the beginning of the year, going through how to find the equation of slope-intercept, and then this concept was all about substitution, all right? So guess what? We're doing the exact same thing, just following some different rules, but we are basically substituting. Here's how you do this. Let's do this one first. I'm given my xy, I'm given my xy. All I need is 2 points, but here's how you always do this. I set up 2 equations on top of each other, like cross products, and see what's going to happen. If y is 16, I don't know my a or my b. I know my x, which is right there, is 2, okay? I put this all over, okay? 64 is equal to ab to the power of 3. Now, let's see how this simplifies. This left side of the equation bar simplifies into 1/4. Well, remember, a to the power of 1 minus a to the power of 1, these a's cancel, which is what we wanted. And I got 2 minus 3 would be to the negative 1, or just keep the power positive, make your life easy, over 1 equals 1 over b. Now, let's solve for b. Well, I do cross products, all right, and I get b is equal to 4. All right, we're almost done. We just figured out what b was. Now I got to solve for a. I got to see what that a value is. So I'm going to go back over here. I'm going to use either one of these points. I'll just use 16, okay? This one, the smaller numbers are always easiest. 16 equals a times b, which is 4, and then x is 2. So this is how you do it every single time. That's a 16 out of 1b. Jesus, I have a hard time. Equals a, well, 4 squared is 16, so this is going to be 16a divided by 16. Again, same process for every single letter. A equals 1. So the equation of this line, right, of this exponential function is y equals, we never write 1 as the coefficient, remember that, okay? Equals just simply 4 to the power of x, and we're done with that one, okay? Now this one's going to have a different y-intercept, and you're going to see how, again, the same process will never change. In fact, I will try to keep that work up and handy for you guys so you can see them side by side. So again, I'm just going to set up, and you set it up just like this every time, and then this lends itself to how that, what we learned the week of Thanksgiving kind of impacts what we're doing now, remembering that when you divide, you always subtract the exponents, and you always want a positive exponent. The difference of 2 and 3 is 1, and I have 1 more downstairs. That's how you got to think about it. Now, going over here, same exact process. Let's do this. So I got 18 equals ab to the power of 2 all over 54 equals ab to the power of 3. Now, eventually this is going to get harder, but just follow the process, all right? So now I know that this is going to simplify to 1 over 3 is equal to, well, the a's cancel. A minus a to the first power minus a to the first power cancels. And I got 1 over b. And again, I do my cross products, and I get b equals 3. Okay, I got b equals 3, so now we're going to solve for the a. And I'm going to go over here, and I'm going to do I'll use the smaller number, it's always easier. 18 equals a, parentheses, 3 to the power of 2. 18 equals, 3 to the power of 2 is 9, 9a. Divide both sides by 9, and 2 equals a. Same exact process. This equation happens to be y equals 2, parentheses, 3 to the power of x. And that's how you do that. Be back in a minute with a couple more examples. Alright, so here's my last example of just 2 raw points. Instead of looking at graphs, it's the same exact thinking. But instead of having consecutive numbers, they're skipping 1. So I'll show you how this works out as well. So in this case, first things first, we always start off with, doesn't matter if I put this on top or this on top, doesn't make a difference, I'm going to keep it consistent. 12 equals ab to the power of 1 all over 108 is equal to ab to the power of 3. Again, I do 1 minus 3, which would be negative 2 up top, or difference of 1 and 3, I got 2 downstairs. So my answer is 1/9 is equal to 1 over b to the second. Now, again, cross products, same exact process, all right? And I get b squared equals 9. Now, the last thing I got to do here when I see a situation like this, well, I'm never solving for b. I'm never solving for b squared. I'm solving for b. So take the inverse of squaring something, so square root it. So b equals 3. All right, now I got to find that a, see what that a is. So I'm going to use the same point, 12 equals a, b is 3 to the power of 1, right? So 12 equals 3a. I divide both sides by 3, and I get a equals 4. So my equation from this, I did all that by doing this kind of work right here. The same kind of work, you have to show the process on everything you do. So this is going to be y equals, your a is 4, your b is 3 to the power of x, okay? Now I'm going to do another one. Right over here, I got bigger numbers. Again, it's going to get more challenging as time goes on, but for right now, just get the process understood and mastered. So, same thing. Let's do this one on top. Who cares? Doesn't make a difference. I'll show you. 240 over 60 is equal to AB. Now put this one on top, keep this one on top. B to the power of 4, and I get AB to the power of 2. So 240 over 60 reduces to 4 over 1 is equal to, my A's cancel again, which is beautiful, and I get B squared over 1. Okay? So again, I multiply cross products, doesn't make a difference, and I get equals to 4 equals B squared. I have to square root both sides, and I get 2 equals B. All right. Now let's find that y-intercept. So I'll use this point now because it's small, it's easier math. 60 equals A times, parentheses 2 to the power of 2, because that's my growth factor. So I'm going to get 60 equals, 2 squared is 4A, divide both sides by 4, and 15 equals A. So my equation over here for this one is y equals 15, 2 to the power of x. That's the bread and butter of what you're doing today. I'll see you guys in class.